So the next project is this tape deck. It's a Onkyo TA-630DM. I picked this up on Craigslist for like 20 bucks or something. It doesn't work, but it was in good cosmetic condition. It has all the knobs and everything. The main reason I got it was primarily nostalgic reasons. So my dad, his first tape deck, like major component, stereo component tape deck that he got was one of these. He bought it probably in 1979 or so, I'm guessing, maybe 1980, and we had it for a very long time. It was used very heavily by my parents for my mom's business. She made tapes all the time, and it was a really good deck, and I used it a lot, and I just have a lot of fond memories of it. And when I saw it there, I just had to grab it. So here it is. Yeah, it's a pretty decent tape deck for this vintage, for this really late 70s, early 80s time. It supports metal tapes, which was kind of a new thing. In fact, there's a different version of this exact deck. It's the TA-630D, and it does not support metal tapes. I believe it actually supports Type 3 tapes, which is a brief period of time when there was this sort of hybrid tape. It was like a chrome ferric tape that was trying to deliver the best of both worlds between a normal tape and a chrome tape. So normal tapes are really good at, like, delivering a warm sound with plenty of bass, but they kind of don't have the greatest high frequency response. And chrome tapes have excellent high frequency responses, but have a little trouble more in the bass area. And so this Type 3 was supposed to give you the best of both worlds, but actually it just kind of gave you the worst of both worlds. So the format didn't live very long, which is why when you look at tape decks that came in the 80s, you never see Type 3. It's always Type 1, Type 2, and Type 4, which is metal. So yeah, this is a very early deck to support metal tapes. It does have Dolby, which is Dolby B in this case. Before they had a Dolby C, so they just called it Dolby back then. And it also has a bias adjustment circuit to allow you to adjust the fine bias on the tape. It produces the two tones that you need when you press this button, and you'd record it, and then you'd play it back, and you'd look at the levels on the meters, and you'd keep tweaking the adjust until you got both the low and the high tone to register about the same on the meter, and then you had your bias tuned in for that tape perfectly. So it's nice to have that built in. A lot of decks that have a bias adjustment don't really have the signal source to do it. You have to sort of supply your own, unless you get to the really high-end ones. So yeah, this is a nice deck. It was well regarded in its time, and even like today, if you read up on tape heads or whatever, people have a lot of positive things to say about it. It's a nice sounding deck. So yeah, I've decided to go ahead and try to bring this boy back to life. So the one we had, we eventually tossed it. I had it for a while when my parents upgraded their deck, and then my sister had it for a while. And then eventually it started acting up pretty bad. In retrospect, it was totally fixable, but the other issue with it was the head was just so badly worn. So my folks used a lot of chrome and metal tapes, which are tough on tape heads. They wear them out quicker. Even though this has a harder head compound, it's their SNS head, Sendust head, I think they called it, which was a different alloy, but still wore them out. And this one has some wear too. It's not nearly as bad as that one was, but we'll see how it goes. I mainly intend for this to be a playback deck anyway. I'm not going to do any recording on it, I don't think. So yeah, I'll show you what it does do, which isn't much. Turn it on. It does light up. One of the bulbs burned out on here. The Dolby light comes on. The AccuBias, this is supposed to light up much brighter than that, my memory. So some of these things look like LEDs when they're actually, I don't think they are LEDs. I bet you this is a light bulb. And I think this also might be a light bulb. That's an LED. These two are LEDs. So yeah, so we got to replace this bulb, but that's cosmetic stuff. I'm mainly interested in the transport, so when you hit play, you can hear the motor running, nothing happens. The auto stop stops it because the take-up reel isn't turning at all. It's alive otherwise. The timer feature works. So it seems good. I'm guessing it needs belts. I mean, I'm sure that's what it is. So what I'm hoping to do is take apart the transport, see how it looks, see if it's salvageable, and fix it up and get it up and running so that it's at least playing tapes again. And then we'll see how the rest of it works out. If it looks good, I'll go ahead and get light bulbs and stuff for it and get the cosmetics part of it sorted out. It needs some cleanup, but it's in really nice shape. The edges aren't beat up at all. There's a couple nicks here and there, just a lot of just from fingers making this all brown. This should all be bright silver, but all the knobs are still there. Some often these are missing. So yeah, I'm cautiously optimistic. So let's tear into it and see what we got. Alright, we'll take the cover off here. So I'm definitely not seeing belts where there should be. Oh yeah. Okay, so unfortunately, it's kind of a worst case scenario with the belts. They have reverted to their former state. Yeah, they turn into this black goo. It's really sticky and slimy and really a pain to clean up. Unfortunately, what happens is once the belts get into this goopy state, you turn it on, the motor runs, and it just sort of flings goo everywhere. So I see it kind of flung around on the brackets and stuff. So this will be a fun one to clean up. But yeah, that's probably, actually let's see if the motor does run. So let's plug it in here. Oh yeah, it runs. So yeah, let's bust this thing apart and start cleaning it up. So usually I start with the front panel, just get that off. You don't always have to take that off. It just kind of depends on the deck, but I'm just looking at all the screws that are here, and there's this plate in the way. I don't think I can come out back. It's going to have to go forward, I think. So get the glass door off the... Actually, no, this whole thing comes off. Let's put that back on. So yeah, I'm just looking to get this panel off. All these knobs are going to have to come off, so it looks like they just pull right off. I think they're all the same. Alright, looks like that'll come off, so I'll take the screws out. Got 3 on the top here, so like pan head or dome head sheet metal screws. Actually, now that I'm looking at the bottom here, I didn't notice this before, but there's it's a separate plate, so you can take this off. Get to the underside if you need to. Debating if I should do that now or later. Let's just see if this comes off. There we go. That'll help cleaning too, getting all these little edges nice and clean. Oh yeah, and the little the little light there is just a little green filter. I see a bulb in here. It's off to the side. There's a gasket that's blocking it. That must be why it looks weird. I decided to go ahead and just take this bottom panel off, even though I won't have the feet anymore. I have a feeling it will help me get the transport better. Still think the transport's going to have to come out, but in any case, less stuff on the way. There we go. We have a dent there, but who cares? This is nice. You can get to the bottom of the circuit board without taking the board out. That'll be handy later. So just looking at the bottom here, yeah, I don't think it really gives me a whole lot of advantage as far as getting the transport out, but I see the screws in the front here need to come out. Looks like it comes straight out the front, so that'll be nice. Alright, so there's 4 screws on the front here that obviously hold it into the frame. So I'm going to put these in a different container. So now I'm on the inside. That way I have inside screws and outside screws, and usually that's enough delineation to figure out what goes where. This thing is built like a tank though, and it's already coming loose, so all that's left is these top ones here, it looks like. These are machine screws. Alright. Interesting. Alright, it's moving. Let's see what else is attached to this thing. Yeah, looks like it comes straight out. Even with the counter attached, there's a hole for it. There's a whole lot of wires on this thing, so let's see. Everything is wire wrapped, unfortunately, so it's wire wrapped on both ends. So that means we can't get it all the way out in a way. We have to leave it attached, which is not unusual, but still very annoying. Cut these tie wraps. Okay, so I just noticed there's this rod here. It's a linkage that goes from here all the way across to the big switch here. So this is those big cutover switches that you see on tape decks. They just reroute all the signals around when you're playing versus recording. There's a bunch of stuff that needs to be switched in and out, so that's what those big sliders are for. And these are what go crazy on older decks. You'll hit record or play, and then the meters will go crazy, or you'll hear all kinds of weird noises out of the deck, and that's just bad connections in this switch. So usually you spray that up and it fixes it. But anyway, you got to get this thing out of here. There's like a whole arm assembly over here to push that. It's crazy. Yep. There it is. Just a piece of piano wire. So I'm going to desolder these two. This white one goes to this switch over here. It's marked rewind switch, and then memory switch. This gray wire goes to the counter. That's to stop the rewind when this hits 0, and this is to stop the rewind when presumably the stops spinning. Take up reel stops spinning. Yeah, so I think at least these two need to get desoldered, so we'll get to that. Should also mention that I am taking pictures along the way. I know I've mentioned this in my previous videos. When you're working on something like this, you'll think you remember, but you won't. Alright. Those two disconnected. There we go. Swing it around. It's a little better. I could probably just lose this thing and get rid of a lot of my wires. I just wanted to show the door eject mechanism on this thing. I didn't notice this before, but it's pretty sophisticated. So normally there's like a dampener, a little cylinder to slow the eject door down to make it look nice and smooth. This one has a string that wraps around this wheel that when you hit the eject button, it winds up this wheel. And the dampener's up here. It's like a little flywheel system. Pretty cute. I want to remove this, so that's why I'm looking at that. It's in my way. I need to get down in there, so let's get that thing out of the way. Alright, so there were a couple of springs. One for take the slack out of that string, and the other one for the door itself. So I remove those. Now the only thing is this belt. Very delicate old belt. There we go. Alright, hopefully I get that wrapped around that thing properly when I put it back together. Yeah, so there's a piece of the belt. It's just mush. See this happen a lot with these belts. They don't always do this though. Sometimes they just dry up and get really hard. But then other times they turn into this goo. I don't really know why one or the other happens. I'm guessing it has something to do with what the belt's made out of. They get sticky. I mean, when they first start getting old, they get dry and hard and polished. And then later on, they start getting soft again, I guess, and they get sticky. So you can see this, what's left of the capstan belt there. It's just kind of a piece of it where I touched it. But it's sort of wrapped around there. So it's not going to come off. I have to just kind of wipe it off. I want to lubricate the capstan anyway, so start cracking into that next. I think this is the light for the tape bay. You know what, let's get the shield off of here. That might give us some more room. So yeah, this counter belt, it's starting, it's still holding together, but it's really loose and getting lots of slack in it. So I'm going to take the motor off next. So there's the motor, all the goop on there. That's nice. Two more wires out of the way. So there we go, we got most of it off of there. So the motor out of the way. Okay, so I'm taking this back plate off. These screws are machine screws with a lock washer on them. Okay, there's a screw in the side here through a hole. I think if we take this off, it's a pretty long screw with a lock washer. Ooh, something came off the other side. There's a little brass bushing. That'll be fun to figure out. Okay, it's out, but I have no idea what just happened. That was on there. There's a pin right here. Trying to figure out where that was. Yeah, so there's a switch here and a spring. And this pin was, I believe it was behind the spring. That's why it's a little piece of spring steel there. It flips this switch up. Spring-loaded switch. Alright. There's a capstan. Oh, there's a spring on it. Sometimes they have a spring. Oh, there we go. Yeah, so there's just a little tensioner spring, that's all. Okay, there's our flywheel. There, I already got it all over my fingers, but what's left of the belt on there. So scrape off what we can. And clean off the rest with denatured alcohol / naphtha or lighter fluid works good. I think mineral spirits would also work, but I don't like that stuff. It leaves a residue. So does naphtha, which is benzene, but you chase it with some denatured alcohol too. Oh, there's a little plastic thrust washer there. Let's not lose that. That was behind the spring. It's going to be our challenge to get this back plate back on. So there's a bunch of little forks that hook onto little levers for all the piano keys and everything that slides around, and that switch with that spring. So it's going to be interesting to get that shoved in there and actually have it work the way it's supposed to. But we'll cross that bridge when we come to it. At least that's all there is to it, pretty much. I mean, everything else in here is just a bunch of steel that slides around. It's pretty dry. There's a little bit of white lithium grease, looks like, on this one piece here. So I may just add to that a bit. It's still slippery, so it's alright. It's not, the grease situation on these fully manual ones is not so important as it is on the logic control ones, where you have motors and solenoids pulling things around. Those need to be properly lubricated. Here, if the grease gets stiff, it's the force of your finger on the piano key that's doing everything. So as long as it doesn't break the piano key off, it kind of doesn't matter that much. And this is mostly dry mechanism anyway, so not too worried about that. That's one nice thing about this type of thing, is they're a little more reliable that way. You know, short of the belts turning back into tree sap or whatever it is it's doing. Alright, got that nice and clean. Set that aside because I got all over my hand, so it's like you clean the spot and then you get it on your hand and then you touch it again and it's round and around you go. So you can kind of take two passes at it. You can get the worst of it off, set everything down, kind of clean your workspace, throw away all your paper towels, go clean your hands, and come back and come at it again, and you won't have quite so much residue getting back on the thing you're trying to clean. So here's where some of the capstan belt flew. So I'll get that out of here. Came off. Nice chunk. That's good. Yep, there's some more down here. On the solenoid. That one came off pretty cleanly, thank God. Some white lithium grease on the back of here. There's some there where the capstan or the flywheel contacts that bushing there. There's a little bit of grease down in here, you can kind of see a little bit. And a little bit over here on some of the slide mechanisms. I know you can't see where I'm pointing, but off to the left there. And a little bit here as well. That's about it. Alright, so the belt carnage is cleaned up, I think. I don't see any more residue anywhere. So that's good. I'm just looking at everything else here, so there's a couple of idlers right here. There's a rubber on rubber. Still feels pretty soft. It's got one little spot where it's been sitting up against the other one. But I was looking on the other side here, so this guy here, there's idlers on this side. This must be for the take-up rails, so I think I'm going to take a closer look at that. That's on the front side. There's no belts, but I just want to look at the condition of the idlers and make sure they're still reasonable. See if I need to do anything to them. These two screws out. Long machine screws with the bushing and a lock nut, or a lock washer rather. There we go. Yeah, that's what I want to see. Get that out of my way. Let's take a look. Yeah, there's a lot of rubber dust everywhere. I don't know if that's just from years of use or if that's like a more recent thing that's been happening. It's kind of like little shavings though, so it's got me concerned. Let's take one of these off. Get a closer look at it. The rubber seems okay. I mean, it bounces back when I try to score it with my nail, so I think it might be okay. I'm just wondering where these shavings are coming from. The only thing I notice is there's a ridge right here in the rubber, like it was contacting almost the whole thing, except for this little edge here. That would be on the front. Yeah, so if it was like that, And what might be happening is it's just every now and then the little tiny ridge just gets kind of peeled off by this brake shoe here. These appear to be the same. So the reverse one looks way better. I guess that makes sense. So yeah, so when you're playing, obviously this take-up reel is being used the most. And only when you're reversing are you using this one. So I think what I'm going to do is I'm going to switch them. Because this one looks really nice. It's in almost perfect shape. And then the junky one, the worn out one, will only be used when you're rewinding. So it'll be used far less, clearly. One thing about this tape deck that I remember distinctly is how fast it rewinds. This rewinds crazy fast. I remember once or twice it ripped the tape right off the end of the reel, which is not a good thing, but it's great for when you were impatient and you wanted to rewind the tape quick. Yeah, so I'm glad I busted into here. So actually, this tape bed looks really nice. Looks way better than the one we had in the old one. I mean, this thing clearly has a lot of hours on it, but the tape head hardly has. I don't feel any ridge at all. And I remember the one we had a deep ridge in it, which probably means they never played a chrome or metal tape on this. I bet you they always use normal tape, which is much easier on the heads and great for people like me who come in decades later and want to use the thing. So that's good news. Yeah, so I'm going to clean up all this mess here. I think I'm going to take down this ridge on this guy with some sandpaper maybe, just to clean it up. And then this will be the new take-up reel. I think that'll work. Okay, I remember now. Yeah, so the way this works is this is the brake shoe. Obviously, like I said, this idler is for fast forward or rewind. It spins much faster. This one up here is the one that drives it during playback. And the reason there's a ridge on this thing is because when it's in there, it doesn't quite reach the entire idler tire. It comes up just short, and that's why it wore that groove into it. So yeah, you can see all the rubber residue on there too. So yeah, it's definitely just a rubber powder, not the broken down rubber goo like the belts. So it's just from wear and tear. I'm not planning to put a whole lot of more hours on this thing. I'm going to put it in my basement system just so when I very occasionally want to play a tape, I can just play it in this guy. You know, when you're fixing these tape decks, put all this work in, and then another 10-20 years down the road, right back where you started. I always try to get the best quality belts I can find. Mars Communications, he sells belts that are imported from Japan instead of the Chinese ones you find on eBay. They're supposedly made to close to the original specifications. I mean, they're from manufacturers that are still making belts, so that's a good sign for Japanese manufacturers. But I don't know for sure how long these will last, but one thing to think about though is, you know, are you really going to use it? Is it worth the effort? And if you do go through with it, don't let the deck sit for, you know, 5-10 years without ever running. One thing that happens, even the belts that are still intact, just from sitting there on the same pulley in the same position for years and years, the belts start to take on like sort of an uneven form. So when the motor's running and the belt's spinning around the pulley, if the belt is, you know, stretched out in one spot and not as much in the other, you'll get flutter. That's where a big source of flutter on your playback is the belt, which seems odd when you think about it, but that again also speaks to the quality of the belts. The belts have to be very uniform. The rubber has to be, you know, just as flexible and just as stretched completely around the entire circumference of it, like perfectly evenly. If it's not, any place where it's a little bit stiffer, it'll slow down ever so slightly and speed back up again, and as it's going around, you'll get this, and that's your flutter. That's where it's coming from. So that's another reason to get quality belts, is to keep the flutter in spec. And I don't have a wow and flutter measuring instrument, but people that do, and who work on decks and buy these cheap aftermarket belts, they find that the deck performs worse after the servicing than it did before, and that's just because the belt is such poor quality. So try to find the best parts you can, because this is a lot of work. So, you know, paying an extra 20 bucks for a belt kit, it's totally worth it. Don't buy the cheapest one you can find, because the hours you're going to put into it are way more than what the belts cost. So I was taking a piece of sandpaper. This is 320 grit. So you don't want to do this sort of thing, because you don't want to make flat spots on a idler like this that is involved in playback. So I'm planning to use this one on the reverse side, so I don't need to worry about it. This is not an auto reverse deck. If there's a little bit of flutter during rewind, I really couldn't care less, so I'm just going the lazy way out. But for the take-up side, I'm definitely not going to do this. I mean, you can drag it on sandpaper. That's kind of a last resort thing I do to bring back an idler. And you just got to be real careful to spin it while you're sliding it, and just try to make a complete revolution before you stop, so that it's, and just try to be as even with the pressure as you possibly can, because you want to take off the same amount all the way around. If you make any flat spots when this is spinning, you'll get a it'll even though the capstan and pinch roller is what's controlling the tape, you have this take-up reel that's kind of yanking at it, you know, and you don't want that. So another thing you can do to take down a layer of this, I've done this, again it's a little risky, but goes a little quicker and it kind of does a more even job. Yeah. So put it in the chuck really gently, like don't torque it down like you normally would, just very gently torque it down, and just go real nice and slow and easy. So there we go. It's definitely smaller than it's supposed to be, but it's still sticking out. The rubber is. All the polished rubber's gone. That ridge is gone. In this case, the drill just, the way this is arranged, the drill grabbed it really nicely, and I was able to spin it on the sandpaper nice and gently. And you know, you want to keep it square to the surface that you're on to keep that flat the way it's supposed to be. And it turned out nice. So it does work. It's very MacGyver-y, but you know, it's really hard to find replacement idler tires, so you got to kind of do what you've got to do. So yeah, that should be fine for rewinding tapes, that's for sure. I decided to go ahead with the rubber renew, so I'm just going to give it a little quick cleaning here. The only way I can tell these apart anymore is the fact that I know that this one is more worn. It's less of the rubber sticking out, but this one's a little taller. So the only issue with that is if this idler can't move enough, but I think it can move plenty, so we'll find out. In any case, the good one's going on the take-up rail side, so worst case is I lost reverse. So now I'm just putting a little rubber new on the idlers on the back side here. Honestly, they look okay. The only concern I have is this one idler's got a little flat spot in it from sitting up against the other one for years, never moving. That gets back to what I was saying before about not exercising these every now and then, you know. You gotta give them a workout. Alright, so it's been a bit of a hiatus, but I need to get back to this thing so I can clear it off my bench. Yeah, I was looking it over to the point now where I start putting the transport back together here. I was looking at these tires again. I was remembering, I don't know if I mentioned this in the previous footage that I shot, but yeah, I figured out what happened with this tire that was all grooved and messed up. So So what it is when you're fast forwarding or rewinding on this transport anyway, this little wheel in the middle here is what drives the take up reels. It shoots over and moves this one or that one depending which side it goes to. But during playback, it's this guy up here that's driving the take up reel. And the take up rail on a tape deck, the tape's moving through the transport at a constant speed because of the capstan and pinch roller. But the take up reel speed varies depending on where you are on the tape. The beginning of the tape it spins quickly because the reel is small, and then as the reel fills up towards the end of the tape, it gets slower and slower and slower. And the motor runs at a constant speed, right? So, you know, how does it account for that change in speed on the take-up side? And what they normally do is there's a clutch, like usually a small felt pad between two plates that, you know, spins, and there's a little spring that gives it some tension. And, you know, all the take-up reel really has to do is keep a constant tension on the reel and spin as fast as it needs to spin. And what happens often with these rubber parts, you know, they dry up and they start to slip. And what I'm guessing probably happened is it started slipping here instead of the clutch. So the clutch is on the other side of this. It's this pulley right here. There's a little clutch in there, and it still works if I grab this. You know, it slips. But as these rubber parts wear out, the clutch sort of overpowers the friction here. So basically, the whole time the tape is playing, this little idler up here, this little brass one, is just spinning on the rubber and just chewing it up, you know, for hours on end. And so that's why there were little shreds of rubber everywhere, probably. So that's probably what happened. Now that the rubber's sort of renewed and grippier again, hopefully that won't happen. Obviously, I'll be watching for that. So yeah, so I think I'm gonna put it back together the opposite way. I'll do the front last, just to help me get at stuff. And so yeah, let's start putting this back together. Hopefully I remember how it goes. Clearing off this flywheel one more time because I've been handling it. Fingers are much cleaner than they were last time, as I recall. A couple drops of sewing machine oil on the capstan here. And we'll drop her in. Looks good. I'm just going to put some lithium grease in there. This is the belt kit that I got from Mars Communications. We got a flat capstan belt and a thicker belt for the drive pulley, and then the thin belt for the counter. It's a pretty small belt, but it looks promising. Yeah, so there you go. So they'll go up around there somewhere. For now, let's just stick it right there. Let's see if we can get this thing on. So, got this little switch, which I remember there was a pin. Yeah, this pin right here needs to go behind this switch, I believe. That's what was giving me trouble before. I'll watch, make sure I don't pinch any of these wires under here. Alright. Need a little help here to guide that guy in there. Alright, kind of in the zone here, but not quite. I forgot to put the spring on this guy. So there's a little plastic bushing. And there was this spring. Actually, I bet you the spring was sitting on there like that. Yep. There. Alright, So that guy's in there. Alright, take you out of the stand here and show you what I'm looking at. So there's a little pin here on the solenoid. It's got to be in this track right here. And the bottom one, I don't know if you can see it, goes right, it's got to be on this side. And then in addition to that, you've got this little fork here. See this little L-shaped piece here? There's a fork on an arm. That's this arm right here. That needs to be engaged with that. This needs to be in that slot there. This needs to be on this side of this here. And this needs to be on that side of that. So it's when you're shoving it in there, there's just a bunch of different things to get just right. And it'll finally pop in, but boy, it puts up a fight. They put up a fight coming out, so. But as always, once you get it in there, just kind of check it carefully. You don't want to clamp it down on top of something. So if it's not sitting flat, there's probably a reason. But it seems to be sitting nice and flat, and it's not really. These little machine screws with lock washers. Yeah, it was this. This goes in here somehow, as I recall. Oh, there's a spring. Yeah, I just remembered. This little guy here. I'll just loosely put that in, and then there was a longer screw here. What side of this plate was the washer on? I didn't notice it when I took it out. It looks like this slides, so I'm going to guess that this little guy slides in here. Yep. And then the screw goes through the whole thing. Like so. So I know the two springs are for the take-up rails. That's where those were from. I got the two little plastic washers for that. Oh, the two screws are from the motor. Alright, so now we got to start thinking about belts. Or more seriously. So the motor goes in like so. Like so. Let me get one screw in the motor here. Stop shifting around. I may have to take it out again. Trying not to touch other stuff. Go. Oh, I see. So to clear this bracket, it doesn't go up, so it would hit it. If I wrap around the back like that. Oh yeah, that does work. Alright, so been screwing around with these idlers. So I was testing the friction between here and here, and took a little bit more rubber off this one with sandpaper, and now it's gripping pretty good. Fast forward also grips nicely on this idler here, but this old one here on reverse was just not grabbing it well at all. It's just not much friction. Now when it's actually running it, it sort of pulls itself in, so it does sort of grab it. But what I found was, just because I had to sand this down so far, because it was already worn down from this thing grinding on it for so long, and I had to make it flat, it just, all this has on it is a little bit of spring tension, whereas the other direction it's got more force. So it was right at the end of its range trying to reach what was left of that tire. So I was like, well, what else can I do? So it's a pretty thick tire, so I took a piece of heat shrink tubing and I sliced a real thin strip and just set it down in the groove, and then set the idler over it, so it's actually stretching the idler out just a little bit, and it brings it out right to about where it should be. I mean, it's pretty even with this one anyway. So it helps, and it looks like it's going to be able to grab it. So I think that salvaged that situation. Sometimes you got to get a little MacGyver on these things. Obviously, the ideal thing is to find a new idler tire, we'll see how it actually performs when it's all back together. Worst case, it doesn't rewind properly, which will be a shame because this thing rewinds like the wind when it works correctly. It's the fastest rewinding cassette deck I've ever seen. Anyway, that's all back together again. So let's put the counter assembly back on. Alright, let's also hope I haven't broken any wires. I gotta figure out these springs and all this string business with that thing. But the first thing I want to do is clean off these pulleys here. They're a little grungy, even though that belt didn't totally expire. It was definitely gooey and it was leaving stuff everywhere. So this thing's making like a scraping noise. I'm trying to figure out what it's rubbing on. Alright, so that's the Hall effect right there. It just senses the magnets moving. Yeah, because it's quiet now, so it's definitely sticking up a little bit, and I really doubt it's supposed to physically rub on it. It needs to be very close, but not that close. Find out if it keeps trying to stop on me. That's what senses the end of the tape. So yeah, if you have a deck that that starts but then keeps stopping, even though it is playing the tape, like if you hold down the key, it plays fine, but as soon as you let go, it stops. It's usually because the belt to the counter broke, and often that's where the sensor is for the pickup. So if this isn't turning, it thinks it's at the end of the tape and it tries to stop it. But it's not scraping anymore, so that's good. Can always tweak it a little if I have to, but I mean there's a minuscule gap there. It's got to be close enough. Alright, so now let's mount this guy back on. Goes like this. That. Alright, so we're getting back to the external screws, not the transport screws. So these two little guys are for the little plate here. So far so good on the belts. Let's put the last one on. The teeny tiny counter belt. So I gotta sneak it behind that sensor. Should have done that when the board was off. There we go. So I'm assuming it goes like that. Looks right. Got one little twist in it. Alright, so before I get it all back together, I kind of want to run the transport under its own power. I have to put the door on before I can get it in there. So I also want to check the light bulb in here. I want to know if that lights up or not. So I'm going to try and power it on. It's still all connected here. The only these two wires that I desoldered are still just desoldered and hanging out. Those are just some sensor wires. We don't have to worry about those. So yeah, let's plug it in and see if it works. Alright, that bulb is not working. That's interesting. Auto stop works. It's a good sign. So let's put the door back on and go from there. Okay, let's get this door back on. It's going to be fun to get this string wound around it again and all that. Alright, it looks like it's moving correctly. So now we get to figure out this mess back here with the springs. Alright, it took a bit of futzing around to get this eject door back on, but it's working pretty well now. It doesn't quite open all the way, but it might work better once the heavy glass door is hanging off of it. Yeah, I struggled a bit with the eject mechanism here. It was just too much friction. It would just stop unwinding after a while. So I took it apart and I oiled the bearings a little bit, and that seemed to help it quite a bit actually. So hopefully that does the trick. It seems to be working. We tested the transport briefly before, so I think it's all good. So I'll put it back in. So before I do that, I'm going to spray the switch because I'm not going to be able to get to it once that board is in the way. Well, I can see the mark from the bracket, so it went this way. There we go. So I got our 2 machine screws that go on top here. Just loosely put those in for now. So it's working good. I was hearing some crackling on the left channel, but it turned out to be my amp up here doing it. So I swapped them down here, and it was still kind of out of the left channel. So that's good. So it's playing fast. I can definitely hear that. There's a lot of tension on the take-up reel. I don't like how much tension it's putting on the tape there. So yeah, so we're kind of down to cosmetic, and then obviously we got to go through the electrical side of it and make sure that it's all calibrated. The outputs look right. Approximately. Yeah, I'll probably just try to find replacements for these light bulbs. Actually, I was looking at how to get this meter out. Let's unplug it here. And it's like, it's held in this bracket that's just held in the case on both ends, and there's really no way to get the bracket out without bending the case. But I finally noticed that they're just sticky taped on there. So there's just a little strip of sticky tape there, and that's it. So they're kind of held by the frame of the front panel, so that's probably why they weren't too worried about it. Yeah, there's just piece of clear tape holding it. It's a delicate mechanism, so I don't want to. There we go. So yeah, this is just a plastic piece. It looks like glass, but it's not. Alright, welcome back. We're going to try to see if we can finish this thing up. So I'm going to focus on the electrical side mostly today, and some, obviously aligning the transport first. I replaced a lot of the capacitors. If you look, you can probably see the little red boxes through here. These are all the capacitors that I removed. It was making some weird, like, rushing noises when you first turned it on, like almost like leaky capacitors or something in the amplifier side. And I kind of like to replace some of the critical caps anyway, the ones that are like in the signal path, the ones doing like DC blocking type duties. This deck, being an older deck, it's all discrete, meaning there's only one integrated circuit in the whole thing, and that's just the Dolby chip. Everything else is discrete. All the amplifiers and preamps and equalization and everything is all done discretely with transistors and capacitors and resistors and all that. So there are a lot of caps in the playback circuit, but it was actually pretty easy to replace them. The schematic was good. The board layout is decent, and the great thing is the bottom of this chassis comes off, so you can get at the bottom of the PCB without taking it out. And not only that, the bottom of the PCB is screen printed with the part designations and little outlines showing all the sections of the circuit, like right on the board. I mean, it's like back when they were thinking about servicing. Right now, that nobody cares because you just throw everything away. But yeah, somebody put some thought into servicing this back when it was designed. So one thing I did figure out since I shot the last footage, I was talking about how I thought the take-up reel had too much torque, and when I was looking through the service manual, studying up on how to do the calibration part of it, there's an adjustment for that. The little clutch here, the wheel back here, there's a little 4 or 3 leaf like spring, and you can spin it on the pulley, and there's 3 positions for it. And the further in it goes, the more relaxed the spring is and the less tension it makes. And it was set to the highest setting, so I just set it to the lowest setting, and the tension's reduced, and now the rubber thing doesn't slip at all anymore. It works great. So pretty happy to find that. So yeah, so let's move on to the calibration. Normally I use a mirror cassette to look at the alignment of the tape transport through the mechanism here. That's just to get the heads like roughly positioned correctly, but there's no adjustment for that on this deck. The one side of the head is just fixed to a post. You could bend the tab if you needed to. I did a quick check just to look at it. It's not perfectly aligned, but it's pretty close, and I'm not going to mess around with it. So I'm just going to move on to the next thing. So see, the next thing kind of the first thing they want you to look at is the tape head alignment. Typically the case. So basically, you play a 10 kilohertz tone and try to get it, to sound the loudest and the most even on the 2 channels. I have my scope hooked up to the output. I also have it on my speakers. So we'll see how it goes. So I can definitely say that this thing has never been aligned. The paint on the screw was still holding the screw. And also, when I adjusted it off that center point, I couldn't really improve it. It was right on. So this thing has held its alignment beautifully. It's good to know. So it's right back where it was. I'm going to check my other tape. This is a cheap Chinese tape. I don't totally trust the alignment on it. I have a alignment tape that I have, but it switches frequencies quickly and it's hard to use. I've also got this 12.5 kilohertz one. I can try that one. Even more challenging. Right about there, as good as it gets. Alright. Alright, so next is to set the speed, which we know is wrong. Alright, so 3 kilohertz tape. There we go. Right in there, 3.05 to 3.01. That's better. Yeah, it was running really fast, but I could hear it in the music I was testing the other day. Alright, so here's where we do a Dolby level calibration. So we're calling for a Dolby level calibration tone. Of course, they have their own magical numbering system for that. They don't tell you what the flux density is. So we're looking for 775 millivolts on that test point. Let's just see how close we are when we play this tape. That seems to be the correct kind of tape. The only thing is I don't have it's properly loaded. They're asking for a 47 kilo ohm dummy load on that. So I'm going to have to do that somehow. Alright, got my makeshift dummy load here. Just to make sure the levels are correct. I have a feeling it won't make any difference, but here we go. We're looking for 775 millivolts. Yep, it's pretty much right where it was. So we're supposed to set the playback level. The right channel looks good. The left channel is a tad high. Turning it down just a touch. There we go. Really close. They were very even. They were just a little bit high, but not off by much at all. So pretty solid. All right, now we're setting the meters. So this is that same procedure again. Using this calibrated tape, which has a very specific magnetic density on it. And the reason you're doing this is because when you're decoding a Dolby encoded tape, it needs to have a reference level that the Dolby encoded to. So assuming that the deck that recorded it was calibrated correctly, which is often not the case, but even if it's close enough, when you're decoding it, you need to de-emphasize it in the exact same way, using the exact same reference voltage. So there's all kinds of amplifiers and stuff on the tape playback side, so you need to get those gains to be set exactly right with respect to the Dolby chip, so it can do its decoding at a known level. And once you have that set up, since the tape gives you a very solid reference, once you get the output amplifiers set right, then those are solid, and then you can adjust the meters to that, and then you have calibrated meters, calibrated playback, and then you can use those meters later to calibrate the record side if you want, which is very handy. At a glance, they look pretty close, but I'm just going to tweak them here. There we go. Pretty much right on. Left channel was just a touch low. Now they're bang on. I didn't touch the right one at all. This is where it gets tricky because the They have specific tapes for specific procedures. It's 10 kilohertz at minus 10. Let's just see what we get out of curiosity. Well, I'm just going to dial this up a bit, try to get the other one close. So let's see. Yeah, they're about the same now. I don't know if it's good or bad, but it's about the same. Alright, moving on. Got a little record linkage hooked back up again. So we forgot about that. Okay, TP105 and TP106. Record. Alright, so I got the bias trap coil calibrated best I can. So now we're going to set up the Dolby circuit. 5 kilohertz, 10 millivolt signal. Alright, 60 millivolts. That is Dolby circuit adjustment complete. Record bias adjustment. Alright. Yeah, so adjusting this bias is very fiddly. You've got two different frequencies, and you record it, play it back each time. You compare the output at the two frequencies, and you adjust the bias to try to get the two to be about the same, but one affects the other, and it's just like this sort of vicious cycle, and eventually you just have to kind of call it. 115, 114, ah, beautiful. Perfect. Alright, let's go back. Check the other frequency just to make sure. Alright, so I got the two frequencies to record and play back at the same level. So that means that the normal bias is set. There are no adjustments on here for chrome or metal bias. It's just fixed, so you can't change those. So yeah, we got one more step to do, and that's the record playback output level adjustment. There we go. I got 775 going in. So now we record this. There we go. 779. There we go. Balls on. All right. Chord levels are set. Looks good. Alright, one more thing to do on this thing. This thing has that extra feature, the AccuBias. Again, don't know if I'll ever use it, but since I'm in here, let's tweak it. Alright, so the procedure is press AccuBias to on. Okay, the balance is fine. Both frequencies are pretty even. Adjust the line output voltage to 110 millivolts with R652. AccuBias is set. I'm going to go back and check my Dolby level. Everything's calibrated. I went ahead and calibrated the recording side too. It seemed to be working okay. It's pretty close. The record level's very touchy, but yeah. Other than that, it seems to be working great. So we're just down to cosmetics now. I ordered bulbs for the meters. They're these strange axial bulbs, a little hard to find, but I managed to find some that should work. They're not exactly the same, but they hopefully will be right. And then this guy is a little light for the to backlight the tape window. It's also burned out. I found a replacement for this as well. It's on its way. And so yeah, putting those in, reattaching things. I cleaned up all the switches already and all these piano keys. Scrubbed them clean. So we should be good to go. Get it back together. Alright, what do you say we try to wrap this thing up? This tape tech project's been going on for a while. So yeah, I was waiting for some light bulbs to come in. Did a little sleuthing around the internet. Managed to find some replacement bulbs for these meters. They're these axial bulbs, and I'll show you one of them. This is one from the. This is the one that's burned out on this guy. They're 6.3 volt AC axial bulbs. They're frosted glass with like a green tint, but the green tint's pretty faded on it. They don't really show up hardly green at all. I did find a pretty close equivalent. As you can see, it's not frosted or green. It is 6.3 volts. I think they're a little lower current though, so the light output's a little bit less than these other ones. And then for the lens back here that lights up behind the tape, so you can see how much tape you have left. I found these bulbs. They are the correct current rating because the service manual actually said what these were, so I was able to find pretty close equivalent. It doesn't have the leads attached on, so I just kind of did my own with heat shrink tubing and stuff. And it's pretty bright. I don't know how bright the other one really was. It seems a little too bright to me. It gets pretty hot, but I will just have to go with it and see how it goes. So anyway, I was trying to figure out what to do with these meter ones. So I was looking for ways to sort of reproduce the effect of the frosted glass and the green coloring. So one thing I tried was a little bit of poly tubing to slide over it, which would give it sort of a frosted effect, and then I have this green transparent tape that I could wrap around that. And so that's what I did for this one, which I've replaced. And this has still got the original bulb in it, which I'm also going to replace just because, you know, if this one's gone, that one's not far behind. So anyway, turn it on, and I'll show you how bright this guy is. He's pretty bright. Lights up the tape backlighting pretty nicely. But yeah, so you can see it's greenish. I don't know how well this shows up on the camera. It's not as bright as this one, and frankly, I don't like the green tint. I think it would be better just natural color. So what I'm going to do is I'm going to replace this one now. I'm just going to put the bulb in straight like it is, and I'll compare the two and see how I like them. Kind of wish I could have found a higher wattage bulb, but the service manual did not give any specs on this bulb, probably because the meter was a contained unit that it has its own part number. The bulb didn't have any part numbers. Trying to be really careful not to do anything drastic. Last thing you want to do is bend that needle, because once you bend it, you can't fix it. You can't make it look right again. Alright, there we go, and we're off. So there's the lens piece. I'll just set this down carefully. So yeah, it looks like a piece of glass, doesn't it? But it's just a plastic molded piece. And on this one, this thing was loose. So I was trying to figure out what this debris was down in here, because it's pretty sealed. They got it all sealed up, and I think what it is the glue that holds this down is like all dried up and coming apart. And I think it's just particles of glue and little bits of orange paint from the needles. The paint's kind of flaking off those. I'm just going to leave those alone. So I crazy glued that one down, so I'll do the same with this one after I clean it up. So anyway, there's the bulb right there. Let me turn it on again. Let's see how bright it is. It's not that bright. I don't know. Alright, let's just desolder this old one here. Alright, so there's the old one. Alright. See how they compare now. So now they both got the same kind of bulb in them. So one's got the pipe and the green tape on it, and the other one does. It's just plain old bulb. Alright, so there's the new bulb, and there's the new bulb with the green filter. I think I just like that one better. It doesn't need the frosted look, it's fine. I'll turn the lights off. So the green does look kind of cool, but you can definitely read the meter better without it. And plus, with the orange color there, I don't know. I think it looks better just without the green filter. So I am going to do that. Okay, so there's my green taped one. pull that off of there. Go. Alright. So yeah, the orange paint was coming off the needles, like just every time I did anything with it, more of it flaked off, so I just took my finger and just went psh, and the rest of it just came right off, so let's leave it at that. I'll have silver needles for now. If I want to paint them at some point, maybe I will, but not today. Alright, so yeah, I'm doing it. Wish me luck. Well, that was a lot easier than I expected it to be. I was afraid it might soak through. Well, that went way better than I expected. I'm not going to touch a thing. I'm just going to walk away and leave it alone. This is what I used to paint it. Just good old Testors model paint. Glowing orange, GL orange. Bright orange, I think, is what it's supposed to be. I was a little skeptical because it looks kind of pink in the bottle, but it looks perfect. Alright, so I think this project has gone on for long enough, so let's bundle this guy up. Alright, I'm just popping those on. I'm not going to tape them in like they were before because the bezel should hold it all together. Alright, let's put the bottom back on. That way it's got some feet to stand on. Alright. Alright, so I think we can put the front panel on. Just gave it a good scrubbing with some warm soapy water and a toothbrush, and it got all the gook off of it, so no harsh chemicals on this one. Let's flip all these up. There's always a risk of taking the pad printing off if you use a harsh chemical on these. Alright, now we got all these LEDs to line up. Yeah, those are held pretty good in place. So yeah, I just realized I forgot about this guy. This is just a little black felt seal that prevents light from coming up through the adjustment hole here. But it was blocking off the light too. The light only lit halfway, which is kind of weird. So I'm going to trim this back a little bit so it's not covering it up so much. There we go. Might get a little more light intrusion, but that's okay. Oh, that went on much better. Face up's definitely the way to go. Alright, so now we got to align this. That's pretty good. Alright, on the money. So this is glass for the door. These are plastic. But they did a nice job trying to make them look the same, I have to say. Anyway, you know, it opens all the way. Alright, last but not least. So it looks like he stuck with me to the end. This one took a little longer than normal, mainly because I was doing it in small increments over the course of several weeks. But anyway, thanks for watching. See you next time.